All right, good morning. So we are going to go over 3.2, just the first part of the notes today, just the first part. And let's go over some vocabulary that you are going to hear for today and for the next lesson. Linear functions are functions that make lines and have a constant rate of change. A nonlinear function, well, they curve. So these are graphs that curve. And do not have a constant rate of change. All right, discrete domain and continuous domain. Discrete is basically individual values or points, where a continuous domain is where you have values that are connected, or points that are connected, also known as an inequality. All right, so let's do, for today, we're just going to do the first couple examples here. So let's go down to example number 1. Does the graph represent a linear or nonlinear function? Explain. So this first one, notice how it curves. So this is nonlinear because it curves. Notice the word linear has the word line in it. And nonlinear is a non-line. So this next one is linear, and because it makes a line. Pretty easy. So you can look at graphs by looking if they curve or if they make lines. Now, what if we have a table? So tables, we have to look for rate of change. So what does that look like? You want to make sure it's consistent. It changes the same amount every time. So let's first look at the x values. From 3 to 6, we're adding 3. From 6 to 9, we're adding 3. From 9 to 12, we're adding 3. Excellent. Now, when I say look for a rate of change, linears have a constant rate of change, which also means it's an adding pattern. So we're going to look down here. We're not looking for multiplication, we're looking for adding. So adding or subtracting, I should put it. So from 36 to 30 is a minus 6, 30 to 24 is minus 6, 24 to 18 is a minus 6. And notice that every single time we have the same rate of change. That means this is linear because it has a constant rate of change. Let's look at example B. From 1 to 3, I'm adding 2. From 3 to 5, I'm adding 2. And from 5 to 7, I'm adding 2. From 2 to 7, I'm adding, 2 to 9, I'm adding 7. I'm thinking ahead here. 9 to 20, I'm adding 11. 20 to 35, I'm adding 15. Notice we're not adding the same thing every time, so this is nonlinear because it does not have a constant rate of change. Remember, at any point you can pause the video, go back to rewrite something just to make sure you stay caught up. So let's go down. You can do these on your own. If you want, you can pause the video, and then when you unpause them, I will share the answers. All right, number 1 is linear. 2 is linear. It doesn't curve. Sorry, not linear, it's nonlinear. It doesn't have a constant rate of change, because notice it makes a V shape. Constant means it's constantly going down or constantly going up. So notice it has the changes, it's going negative, and then it changes to go positive, which is a non-linear function. All right, let's look at these tables when you did those. The first one is a linear function. The second one is non-linear. The second one, you're dividing by 2 every time, but the pattern has to be adding or subtracting for it to be a constant rate of change. All right, last example for these notes is example 3. We want to identify which of the following equations is a function. So here's some rules for functions. It's about looking at the variable. So look at the variable. The variable cannot be in square roots. The variable cannot be an exponent. It cannot have an exponent. It cannot be in the denominator of a fraction. So let's look and see which ones of these are. So if we see any of this stuff over here, it's not a function. So let's look at this first one. 3.8. Y equals 3.8. Notice there's no variable in square root symbols. There's no variables with exponents. There's no variables as exponents. There's no variables in the denominator. So this one works. So I might circle that one. Notice this next one, I have a variable inside of a square root function, so it doesn't work. This next one right here, I have a variable as an exponent. Doesn't work. This next one, I have my variable in the denominator. Doesn't work. And if you ever go back and we graph those, when we show you how to do it in the graphing calculator, they will make curves. They're not going to make lines. This next one here, notice I have distributive property. Even if I did that, I get 6x minus 6. And notice my variable does not show up in a square root symbol. It doesn't have an exponent. It's not in the denominator. It's not an exponent itself. So this one works. In this last one, we have an exponent here, which means it's not. All right. Good luck, and we'll see you here next time.